In this video, we'd like to define cylindrical coordinates. So here's the basic idea. Remember that to describe a point in three-dimensional space, we always need three pieces of information. And usually, or what we're used to in rectangular coordinates, is that if this is our point P, then we can describe this point by saying how far we must travel out the x-axis. We call this, say, the x-coordinate. I'll call it x0 since I've labeled the axes this way. And then how far we must travel in the y direction. And so that distance over here is called y0. And then finally, how far we have to travel vertically in the z direction. And this height up here we'll call z0. And then to describe this point, we just say, okay, well, in order, always in order, x, y, z, we just say the coordinates of this point are x0, y0, and then z0. This is perfectly fine, but there are times when we would rather describe this point in a slightly different manner. So the same point here, so right now, the way that we're thinking of this is that this point lives on the corner of a box. So the corner of a box, pretend this is a well-built box, but the corner of a box that is completely opposite. So the corner of this box is completely opposite the corner that is at the origin. And this is why we call this rectangular coordinates, because a box is just a rectangular prism. Alright, well, instead of thinking of the geometry like this, where this point lives on the corner of a box, we can think of this point as living on a cylinder that's centered around the origin. Okay, and so here's how this works. What we do is instead of building a rectangle in the base, we can build a circle. So we can project the point P down to the xy plane, and we can think of this point as having polar coordinates. Okay, so this point right here lives on a circle in the xy plane, and its polar coordinates here are r and theta, the usual polar coordinates of this point that sits below our point P. So the coordinates in the xy plane, the polar coordinates in the xy plane are r and theta, the radius and then the angle that's subtended from the positive x-axis outward toward the positive y-axis. And then, now that we're sitting just directly below this point, we can see that this height is still z. This height is still z. And so cylindrical coordinates, all they do is they take this point P and they switch the first two components. They switch the rectangular components to become polar components. So our point P in cylindrical components, or cylindrical coordinates, is going to be described by the radius r. That's the distance in the xy plane away from the origin. The angle theta, that's the rotation in the xy plane. And then the height z is still the same. So the height z is still the rectangular height. And the reason this is called cylindrical coordinates is because we can see this circular shape in the xy plane. This circle is extended up all the way through space, and we can now think of this point P as lying on the edge of a cylinder whose radius is r, okay, and the height of the point on the cylinder is z, and then the angle of rotation in the xy plane, the angle of rotation from the x-axis to the y-axis in the usual orientation, that's the angle theta. Okay, and so we are going to use these coordinates. This is a coordinate transformation that does not move the point. All right, this coordinate transformation does not move the point, but the way that it works is, of course, since this is polar coordinates that we already understand pretty well, the way that it works is this, our t, r, theta, z. If we're going to convert from cylindrical to rectangular coordinates, then our x and our y have to be written in polar, and z just remains the same. So our transformation, our coordinate transformation, is just that x equals r cosine of theta, y equals r sine of theta, and z is just z. So, I mean, this is kind of weird, but this is just saying, okay, that's the identity. We haven't changed the way we think of z at all. We haven't changed the point at all either. We haven't moved the point, but we've changed our perspective on the x and y coordinates only, and not the z coordinate. And so this is the cylindrical coordinate transformation. It really just changes the xy coordinates to polar, and it leaves the z coordinate in rectangular in some sense.